Hello everyone, hope you're doing well. Today in this lecture, I'm going to explain you how to write an ALP to search a key element in the list of numbers. The searching method followed here is linear search. The linear search, or also called as sequential search, is a method for finding an element within the given list. It sequentially checks each element of the list until the desired element is found. The advantage of using linear search is the list need not be sorted. Unlike a binary search, linear searching does not require an ordered list. And also, it is not affected by insertion and deletion of new elements. The disadvantage of linear search is a greater time complexities compared to other searching algorithms. Okay, so before I start explaining you the code, we are going to use a new concept in this program called macro. A macro is a group of instructions to which a name is given. Each time a macro is called in a program, the assembler will replace the macro name with a group of instruction. Okay, basically what it says is when a small set of instructions need to be executed repeatedly, we are going to write those set of instructions separately in a program and call those set of instructions whenever needed with the help of a macro. The advantage of using macro is macro reduces the amount of repetitive coding. Program becomes more readable and simple. Macro reduces errors caused by repetitive coding. Now let us learn how to define a macro. Before using macros, we have to define them. Macros are defined before the definition of segments. Assembler provides two directives for defining a macro. One is macro macro and endm. Macro directive informs the assembler the beginning of the macro. The general form is macro name. It is a user defined name. Any name that you want, you can give it. Followed by macro, the keyword. This should not be changed. Followed by the arguments. The main programs is going to send the actual parameters to the macro. Here, I'm going to accept that as a formal parameters. Arguments are totally optional. End M informs the assembler the end of macro. Its general form is endm. Make a note, there is no space between n and m. It is continuous. Now let us see one example of defining a macro. Suppose you need to execute some set of instructions repeatedly. Say you want to print multiple messages. Like we all have learned, for printing a string, we have a service number called 9. So the usual instruction that we follow to print a string is move h, 09h, lea dx, message, int 21h. These are the 3 lines that we use to print a string. Now, I'll show you an example here. I've called the macro name here as display. Space macro is the keyword, which you can see it in the red color. Space msg is the arguments that will be accepted here in the main program sensor. The code inside the macro are move h, 09h, lea dx, message, and int 21h. And end the macro by using a directive endm. A quick recap. Display is the name of the macro. Macro is the keyword used. and MSG is the argument passed. And code inside the macro are the instructions to print a string, and ENDM is the end of macro. Now, let me explain you an assembly language program to search a key element in a list of numbers. The output for this program will be either key found or key not found. So I'll just open a notepad and explain you the program. The first line of every program says dot model small. It is an assembler directive which tells the assembler that I'll be using one code segment and one data segment. Next line is dot data. It is also an assembler directive which tells the assembler that whatever I'm going to write next should be stored in the data segment. Now I'm going to initialize the array element for searching by giving the variable name as str. str db numbers 11, 22, 33, 44, and 55. str is a variable name followed by db defined by and the array of elements. Now 5 bytes will be allocated in the memory and will be assigned with the elements given. This is how the memory segment looks, where 5 locations is being reserved and initialized with 11, 22, 33, 44, 55. The addresses to that 2000, 2001, 2002, 2003, 2004, 2005. And the variable name is given as str to the starting location of my data. Coming back to our program. Then we need to define two messages that say whether the key is found or not found. I'm going to define that here by calling the variable name for the first message as message1 db in double quotes key found. All the strings should be terminated by a dollar. And second message, I call it with a variable message2 db key not found, again terminated by the dollar. Now the element that need to be searched is also defined in the data segment. Say I want to search a key 44. So I'll define here as key db 44h. Now we are going to write a macro for displaying the strings. Now I call here a macro name as print followed by a keyword macro, and the argument I'll give it as MSG. Now the set of instruction what I need to execute repeatedly, I'm going to write here OH comma 09H LEA DX comma message int 21H. Then end the macro by using the directive END-YUM. Now whenever I need to execute these three instructions repeatedly, I'm going to call a macro by its name and sending the corresponding arguments. Now I'm moving on to the code segment dot code. We know that we have to initialize the data segment by using these two instructions, move ax comma @ data move ds comma ax. Now the key element that I need to search, I'll move it to some register al. Move al comma key. Now I need one index register in the data segment to point at my first element where str is pointing. So I basically want the index register to hold the address of str. So for that, I write a instruction called LEA, load the effective address of str to si. So LEA si comma str. Now I'll show you in the data segment what happens. Now si comes and points to str. Going back to your program. Now I need to have a count of the numbers initialized, because when I start searching linearly, I have to stop at some point. So I initialize a counter here. Once the counter becomes 0, that means I've searched all the elements. So as I've entered 5 numbers, I'll initialize the counter register with 5. Now I take the first element from the array and compare it with my key element. If it matches, I directly go to a message and say key found. If not, I keep incrementing one by one and start searching. Even after searching all the elements, if it doesn't match with my key element, I print a message stating key not found. So now I move the first element to some BL register. What I did here is move BL comma contents of SI. I'll show you in a data segment what is content of SI. SI is pointing to 2000. Contents of 2000 is 11. So going back here, that 11 will be moved to BL. Now I need to compare that key element AL with BL. Compare usually does this subtraction. If AL and BL are same, the result will be 0. That means the element is in the first location itself. So if it is in the first element only, so I write an instruction jump 0, some label name found. I go to label name found here, and I need to print key found. So for printing, we have written a macro. So I call a macro name print, and which parameter I need to send message 1, because message 1 holds key found. So I go here and send the argument as message 1. Now in this program, as we see, AL and BL are not same. So I have to search the next element. So I increment SI. So here what happens? I go to the data segment. SI now increments to 2001. Coming back to your program. As I finish searching the first element, the CX register should be decremented. So I write decrement CX. CX will now be 4. Till when I'll be repeating this loop? Until CX becomes 0. To make sure I've searched all the elements in an array. As now CX is not 0, jump if not 0, go to the label up. Up should come and point here. Now again, If you trace back, move BL comma contents of SI. Let me see in the data segment. SI is having 2001. The contents of 2001 is 22. 22 will now be compared with AL, which is my key 44. As it is not 0, it will go increment SI. Now SI will be incremented to the next item on the list, decrement CX. CX will now become 3, jump if not 0 up. Yes, it is not 0, it goes back. Again, it says just the same thing. Once 44 is compared with 44, it becomes 0. At that time, jump 0, it goes to the label found and prints message 1. After that, I write a termination instruction. Move AH, comma 4CH int 21H and END. Now, what suppose after searching all the elements, the key is not found? At that time, it comes out of the loop when CX becomes 0. It decrements, keep on decrementing CX. When CX becomes 0, it comes out of the loop. And now I have to simply print, call the macro print and send the second argument MSG2, key not found. So here I'll call a macro print space message2. So the program prints the output as key not found. After that, the assembler goes to the next line here and again it prints key found. That is not the proper way. So I have to tell my assembler after printing the message 2 stating key not found, you have to directly jump to the exit instruction. So I'll use a unconditional jump JMP exit. So processor after printing message 2 as key not found, it jumps to the label exit and terminates my program. Move H, 4CH in 21H is used to terminate, and END says it is the end of assembly language program. I hope you have understood this program. Now I'll show how this program is executed. So for that, we are using DOSBox. As you know here, we have to mount C:/mason C and edit linsr.asm. And this is the program. The same program what I traced and explained you, I've written here. You save it, exit, compile the program. Mason search.asm. Yeah, you made sure there are no errors. Link.obj. Finally, give a file name. Key not found. Why? Because you can check the key given in the program is 88, which is not in the array elements. Now I'll give it key db44h, save the program, go back, compile it again, no errors, link it. Now give the file name. It says key found. I hope the things are clear. In my next lecture, I'm going to explain you the palindrome program. Thank you.